Hey, I'm Ian Bernstein, founder and head of product at Misty Robotics, and today we're going to talk about the technology inside of Misty. And I'm here with Morgan Bell. Who are you, Morgan?
I'm the head of engineering here at Misty Robotics. Been working on this project for nearly 4 years in total now, from the very beginning.
Yeah, back when we were at Sphero, right? It was like we had an off-site lab at Sphero, and we were kind of behind a hair salon and
a yoga studio. Yeah, and an old plumbing garage. Yeah, it was sketchy. It was a sketchy building.
Yeah, and I think we started as an R&D team within Sphero and got so excited about what we call the Home Robot Project. And I think you were the first engineer, the first senior engineer that we hired onto the project. And at that point at Sphero, we were still looking for that killer application for Misty. We probably went through, back at Sphero, maybe 150 different iterations at least on the design. Do you remember like some of the names of those early ones?
You know, the Mars ones were some of the earlier ones, and that it was really a better test mule for sensors and things than it was an actual form factor. We went through a bunch of locomotion designs where we had, like 2 wheels in the back and a wheel in the front, or a uniball thing in the front, or we had a Sphero in the front on one. We were trying to sort of power it in both.
Wheels, right?
Yeah, we tried to, and we had a torso that would raise up from there. At the time, the legs would articulate independently, and the torso would articulate. And holy crap, was that hard to make, right? That kind of stuff. Just getting a 3D printed maquette took days and days and days worth of failed 3D prints, right? So we learned a lot of those. Those were the Rover series ones. And we had probably like 3 designs in that series. And they're all either the wrong size or there's not enough interior volume to do anything with. You can't put stuff in it. We had Hoot, which was the ball, and then we sort of...
It's more the Sphero-shaped one.
Exactly. It was sort of like a colossal Sphero, but on wheels. It was not stable in any sense of the word. As we went through some of the early prototypes, they were good at sort of one thing, or they had sort of a very specific case or purpose where they would fit. Like Hoot was a great example. It was neat, but it wouldn't be a great development platform because it really didn't do enough, but it could serve a specific use case around maybe mapping or something like that.
I think like every week it was something different, right? One week it was like a security robot, and the next weekend it was like an elder care robot. And it took probably a year into you joining that we finally decided that we should make a development platform.
When we moved to a development platform, it became infinitely more challenging because everything that could have been made clear was really vague and it really, really broad. So you couldn't just implement one really great experience. You had to implement 45 good experiences. And so the breadth of the platform became its own set of challenges, right? You didn't need, I needed a computer vision specialist and an audio specialist and an API designer and, right? If you're building one experience, then you just have one sort of thing. We've gotten through it, and we've certainly come out with a platform that is broad and deep enough in the right ways to where people can build those really specific use cases and sort of get to the value they're looking for.
How about walk us through just kind of an overview of the system architecture? The different pieces, there's the real-time controller and maybe the communication, how those communicate.
So the way it's set up is there's really, you can think of either 4 or 5 primary modules doing primary things. So there's a real-time controller, which is really responsible for sensor readings, interacting with simple outputs, things like lights and time-of-flight sensors and that kind of stuff. And then we have a motor controller that sits on that, and that's responsible for making sure that the feedback loops to the motors are tight and that you're able to control motors with high precision or at high speed if you need to. And then there's CAN communication between the two, so they share data back and forth. So if a time-of-flight sensor says, hey, there's an obstacle in front of me, the motors can go, oh, hold on, let's not crash into that, right? Both of those communicate over that same CAN bus network back to the headboard, which is 2 compute modules on there, the 2 Qualcomm SOMs. One of them is really the aggregator. It's a controller for all this stuff, and it hosts a series of APIs, and it hosts sort of all of the means for aggregating data and servicing it back to the user. and then abstracting some of those lower level control commands, right? You don't need to know necessarily how a PID loop works in order to smoothly drive the robot or smoothly move the head, right? And then on the other side, there's the A20, which does all of the computer vision. So it's doing everything from camera frames coming in to communication with the occipital sensor, all of the depth calculations and all of that kind of work. And then those two communicate over an Ethernet network that's baked into the carrier board we have for those two SOMs.
So, I mean, there's a crazy amount of technology inside Misty, right? And it is not simple. Multiple microcontrollers, multiple processors running different operating systems. It's really complicated, but it's not complicated for our developer, right? I mean, we put an enormous amount of energy into making sure that all of that complicated technology just to get the robot to be useful and do interesting things like recognize your voice and map and move around, right? We're trying to hide all that so that developers, like, what does it mean to the developer? You know, what do they see on their side?
Yeah, I think what the developer sees is APIs and interfaces that give them access to data at a grain that makes sense for what they're doing. You know, there's cases where you want to be able to manage the stream of data from the time of flight sensor, right? Because there's a use case where you're going to want to do that. There's other cases where you want to touch a location on a map on the tablet and you want the robot to drive there, and you don't want to know about all of the nonsense that has to go on to make that work. There's so much heavy lifting that has to go on in those lower layers. But I think we've done a good job of abstracting away some of those details so that you can focus on how does a robot do things in the real world and how do I get value out of it, rather than worrying about, you know, how do I take a three-dimensional mesh of the world and flatten it into an occupancy grid. That's a really huge problem. And to not have to solve that and to instead be able to say, the robot's spatially aware, and if you want it to go over there, you just tell it to go over there. I think that's super cool, and I think that's a big advantage to our developers.
Our software is probably not going to be perfect, right, when we launch the product and start shipping.
I have it on good authority that it's perfect.
Okay. Our software is perfect. We may do software updates.
We're going to do a lot of software updates.
So we want to know if you already have a Misty already, if you're a field trial customer or an early customer, or you're getting a Misty soon. Morgan, you probably want to know about any issues that people are having, features they want to maybe get implemented next, so they should reach out to us via the forums, right?
Yeah, absolutely. We know that we aren't going to have everything there on day one, right? It's a broad platform. There's a lot of stuff there, and we can make every bit of it infinitely better. We just need to know what people want, right? It's a prioritization question. We're going to be updating it all the time. The course plan is to try to have an update delivered to the field every couple of weeks, and we definitely want to hear where things work really well and where they don't work really well, because we want to make those experiences really great.
Cool. So let us know. You can check out Misty Robotics, mistyrobotics.com. There's community forums where you can get engaged with the community and us. Yeah, it's exciting.
It is exciting. We're excited to see what people build.
Yeah, excited to see what you guys build.